Hi, Stuart again. Today we're going to talk about the journaling pattern. Journaling as an idea is really simple. We allow a data source to have inserts and no updates or deletes, but of course we allow reads. So the canonical example is a worm drive, often used for storing documents for compliance purposes. But journal storage can be used in all sorts of application scenarios, and that's what we're going to talk about today. And the idea behind a journal is a little bit like the idea behind Paculli's two-sided accounting journals. You write a record from one to the other, you don't allow deletions, and if you need to make a correction, then you write a new record. That is an adjustment. So it's all about pluses and minuses. And a key thing about digesting is that we need to roll up all the pluses and minuses and come up with the current state or value. And so stock trading, auction systems, comment streams, or comment streams with votes like feature voting, for example, are good examples of where the journaling pattern would be very powerful and useful. So when we design journal storage, and you can implement these pretty much anywhere that you can protect the journal from being deleted or updated, except by the system of authority that does the end-of-day processing. We'll get to that in a little bit. So here's an example of buying and selling stocks. We have a very simple two kinds of stocks, and we have two kinds of orders, buying and selling. Super easy and simple for this example. And so we are collecting these buy and sell orders, and in intervals, we need to adjust the overall stock price to reflect the trades that have gone through. And that's an example of digesting. If this was an auctioning system, these would represent the bids, and we'd want to know what the current bid price is. And so digesting almost always involves some sort of aggregation. An aggregation is a function over a range of values or rows with a selection. In this case, the selection is either ABC or OBX. So you can imagine what, for example, the SQL statement for a digest might be. And usually what happens is that these journals, in order to keep them relatively small, and I say relatively because if you have 100 million trades a day, that's still a pretty good sized journal table. And you may even want to consider breaking out your journal by partitioning so that a particular issue or item or collection of items gets a different journal file to keep the vertical height of the journal file fairly small. And again, you want to trade off the fact that we're going to have to do some computing to figure out which journal fragment to write something to versus the cost of computing that write. Generally, storage is cheap, and we also want to consider the engine performance doing the journaling. So are we using a relational database? Are we using a document database, which would be a good choice? Are we using a bucket like S3, and we're just aggregating all the transactions as files into the bucket, and so on and so forth? There are even purpose-built systems to support journaling, including some built entirely in hardware. In very large systems, in-memory databases are often used for that on hardware that is as exotic as it is huge in RAM because the relative computation part is fairly easy. Many of those systems use custom chipsets or the GPU to do the digesting because they can do enormous amounts of calculation. Other systems are based on a queue with multiple consumers or cursors for the same queue. You can go see my queuing lecture to learn more about that. And so different things are doing are consumers of our journal. So we might have something executing the trades. We might have something capturing the trades. We might have something streaming the trades to a reporting system. We might have it streaming to one or more digesters. So for example, we might have different digesters that are looking at the overall velocity of buying and selling versus the current share price, for example. So you can combine journaling with other cloud patterns to solve a number of interesting problems. So here's a typical journal flow where the top is the entry point where we do our inserting. And as we do that, they get a transaction index of some variety. And we have a digester, and the digester goes through and it figures out based on the old digest and where the digest left off. So we know we have to look at ABC starting at index 1987, but greater than that, because that's as of 1987, the price was 43.13. For OBX, we need to start looking at beyond journal entry 1392 and so on. And so you can see that the digester, right, is able to start off where it left off last time. And by adding up all the buying and selling grouped by the ordering price, we can compute a new price. Now, the actual math for computing buying and selling is way more complicated than I've shown here. But we're just assuming the digester knows how to properly implement the algorithm for determining a stock price. And the idea that the previous digest feeds the next digest and so forth. Okay? So, again, some common digesting scenarios on item trades and auctions. I wanted to talk about auctions for a minute because they're interesting in the sense that if there's a reserve price, the item with its reserve price can be considered a bid, and you can write that into your journal. And the digester doesn't know or care about that entry different than any others. And of course, it's only going to increment the highest bid price if it finds a trade after the digest, sometimes called the tombstone, right? We mark the last place we digested each item as a tombstone. And so if the reserve price continues to be greater than any of the bids for that item that came before it, the reserve price remains. And if any bid exceeds the reserve price, it becomes the new auction value for that item. And in that way, when the auction is resolved, we can say, well, which entry won the bid, and if it is not the reserve price, then we say, okay, who made that bid? Can they make good on it, and so forth? And there's a whole resolution algorithm. And of course, if it's the reserve price, then the auction closes without the item being sold to anyone. So you can do the digesting via, streaming, pub/sub, sampling. There's all kinds of techniques for digesting. And which one you pick is a function of your business requirements. So sampling is good when there's a lot of information and you really only care about the overall gestalt of the thing. Voting is an example of that. If you have people doing a +1 on something or a thumbs up or, a smiley face or whatever, then sampling is really great because we don't actually have to walk all the records. We just have to take a statistical sample. and we can see the overall trend, and there's no financial consequence to sampling. Sampling is also good when the population N is very, very large, and the population is the entire population, statistically speaking. So we can think about what an end-of-day process would look like. We stop accepting records into our journal. At some point, the digester will catch up and will produce an end-of-day set of values, those that are in orange. But of course, those are also the starting values for the next day. And so we can extract our records into separate journals or some other mechanism. In this case, I've chosen to separate them by stock issue, but you could have your own scheme. And of course, each one of those either succeeded or failed as an atomic operation. And there are lots of different atomic operations. And so you use that longer running math against the digest to create the end of day tombstone, which becomes the start for the next day. And then you reset your index by emptying out the index. Remember, we moved the records into someplace safe that we're going to keep forever and ever, or at least a long time. And we can reset our index and create an empty queue. And you'll notice that I say that explicitly because it's generally better from a performance point of view if you have a way of pre-allocating the expected volume. Then the inserts don't have to wait for the indexes or the storage to be expanded. And the other rubric is never make small extensions in journals, right? If you find yourself getting within a certain tolerance of the allocated size, then you should allocate a significant allocation in little chunks, right? One right after the other, so that you will not need to reallocate again. Just an efficiency thing.